I'm going to apologize again that we do not have calculators for everyone because, again, my calculators have gone missing and all of my messages about where my calculators has been ignored. But we're on. My pen just went crazy. Part 1 of function modeling. This should feel somewhat like a review. We did quite a bit of function modeling in Algebra 2. So hopefully it doesn't feel like brand new information. So the goal here is to describe whether it's a linear, polynomial, or piecewise defined function, meaning that it's a piece of all types of functions coming together to make one big function. Last year in Algebra 2, we talked about regression models. We talked about how to determine what level of a polynomial we're looking at. So we talk about first difference, second difference, third difference. Is this ringing any bell? Or you found the difference? If it's a first difference, then it's a linear. Second difference, it's a quadratic. Third difference, cubic. Fourth difference, quartic, and it kept going on, right? Those common differences. And so what we're doing here is identifying similar patterns and establishing what is our closest relationship happening. So here it says an antique dealer visited an auction house and recorded an estimated selling price of 6 different antique chests. Then he checked the actual selling prices after the auction ended. The data points estimate actual, show the results where each number is in thousands of dollars. So what we have here, what we're going to do here is scatter plots. The reason why we're going to do a scatter plot is because in order to use the first, second, third difference, this has to be an equal distance apart between each number. Are these equal distances between the numbers? No, it's not even in order, but still it would be 5, 7, 8, 9, 10.5, and 12.5, right? And so that equal distance doesn't exist, which means that we can't just find it. So we're going to create the scatter plot and analyze what it looks like. Does that make sense? So I'm going to go to 12.5. and go up to 11. So 12.5 up to 11. Sorry. Estimate to the actual. Like the margin of error. Yes. So this is going to be our X and this is going to be our Y. So I'm going to go to 12.5. I'm going to go up to 11. Okay. Now I'm going to, I don't know, 8. I'm going to go up to 9.5. I'm going to go to 10.5, go to 5. I'm going to go to 9, go to 10. I'm going to go to 7 and go to 6.5. Why am I there? I skipped 5. I went. It disappeared. It erased it.
No, I think you said 10.5, 5.
Yeah. Did I? Oh. Well, then it was me. What's wrong? What were you saying? Okay, so for the most part, when I look at this, it is linear, right? So I can kind of create, I'm going to go to my highlighter, and I can kind of see that there is an upward, oh, I didn't do that. My pen did it, so. It doesn't want me to draw.
Wait, is that not supposed to be by that other guy?
Yeah.
Yes.
So.
All right. So when you have your regression model, it's supposed to be like the line that is the least amount of different distances between all, like, I don't know why it's doing that at the top. I have no clue. It doesn't want me to be great. What is wrong with my thing?
We're going to 0, right?
Almost. Okay, I'm not doing it again. It's not the best one because it's too far from the other one, but your regression, your trend line is the line that has the least amount of squares. Remember that word, the squares? In between, it's a sketch, it's an effort. But what you're gonna do here is that once you have placed it, create the line, if we're gonna estimate by hand, we talked about you just find where you start, finding the average rate of change from where you start to where you end, right? That's by hand. If I'm gonna do it with calculator, it's a little more accurate, but we're gonna do it by hand, and then we're gonna review how to do it by calculator. Is that cool?
Yeah.
All right. So by hand, all you're gonna do is highlight what is your lowest point and what is your highest point and find their average rate of change and the line that connects them. Okay?
So it's the 5 version.
Yes, it's a very low estimate. So it'd be 5 and 3.9 is our low, and our high is 12.5 and 11. Agreed? So between these two, we're gonna find our rate of change. So we have 11 minus 3.9. Because rate of change is the change in your y over the change in your x. And then we have 12.5 minus 5. 11 minus 3.9 is going to give me 7.1. Agreed? 12.5 minus 5 is going to give me 7.5. I'm going to put this in the calculator to get an approximate rate of change. Anyone?
0.946.
946.
946.
We'll take it.
Wait, we didn't round up because it's 6 continuous.
Let's just round to 5 then. Is that cool? We'll just do 5 instead of rounding. Okay, now this is my slope. So we're gonna find our y-intercept. So we're using y equals mx plus b, correct? Because it's a linear. You can choose any point on here to use for x and y. Any point from your table can be your x and your y. 9 and 10. All right, so we're going to do 10 equals 0.95 times 9 plus b. I want us to show, I'm going to show you the difference, what's going to happen. It's a 9. Okay, so if we choose these two from the table, it's going to create a different b than choosing any other one. What the calculator does is it finds all of those and finds the best fit. Okay, we're not going to do that. Okay, we're just modeling how to find b and recalling how to find b. We multiply and we'll do what? Subtract. So if we have 9 times 0.95 and then 10 minus that. Well, yeah. So what would my b be? 1.45, right? So if I use this slope for all of them, they're going to give me a different b. I subtracted, right? The other way. And also our line is positive. Okay, now, what you're going to do, if this is on the non-calculator part where you don't have your graphing calculator, this means that it only wants you to use the numbers you highlighted. You're not going to have to go through and do every single one of these and find their average to find your best b. Does that make sense? You're only going to use the ones that you highlighted. So out of these two, which one would you want to use?
Well, the smaller one.
The smaller one's usually the best bet. So if I use the smaller, that's 3.9 equals. It's going to be the same. Yeah. So we have our m. Our m is not going to change. It's still 9,500 times 5 plus b. Again, we multiply and subtract to find our b. And when we do that here, what do we end up getting?
Negative 8.5.
Part. Mhm.
So why do you have to choose that?
I'm showing you the difference. Okay. So this one right here is good if you're going to find it for every single one. Does that make sense? And you're trying to find the best, like overall, more accurate estimation. This one is the one you want to do
But I don't see the difference
between the B values.
It's like a numeric.
It's a numeric. So like, and this is a more accurate. So if you look right here, notice when we were trying to create a line that goes through as many, well, as least squares away from each point. If you look, where is this heading? It's heading below 0, right? So this is telling us that this is a better accurate because we're using our beginning and our ending. Okay. So a lot of times we want to choose numbers that look the easiest to utilize, but just use the numbers that you utilize to create that slope.
But we use the same equation.
You're using y plus mx plus b. Yes. But you want to make sure that you stick to whatever numbers you choose in the beginning, no matter how big or decimals or fractions they are. Those are the numbers you stick to throughout the whole problem. Okay.
And you only choose them to the highest number.
There, your highest is where it starts and where it ends.
So,
So our equation is, what's our slope? 0.85. So your highest and your low. Okay.
So we could have created if I use the highest. Or the more accurate one is the smaller one. Like just all of them.
Out of the two yellow ones, they're going to both produce 85.
Okay. So they'll both be the same, but it was just on.
Which is math. If you're on a non-calculator part and you have to multiply, don't you want to multiply with smaller numbers and divide with smaller numbers if have to?
So now you have to have a
You still need to have those basic math skills available. What?
I was thinking over time, like,
On non-calculator, it means non-calculator. Yeah. Remember, I posted the format that they released to us. So we're gonna do a mock. We're gonna do a mock one in January. No, because it's over the whole year. That's not fair to y'all. All right. Okay. Now we're gonna try this again. So this time, I'm not gonna tell you. You're gonna do it yourselves. Got it? Okay. After you do it this way, after you do it numerically, we're then gonna do it with the handheld. Okay. No, we're gonna do it. I want you to practice using the method we just did with high and low. And then we'll do it the calculator steps together. So practicing.
We're using our overall biggest numbers, like the highest money values are 37, that's not the highest value. Yeah, I'm using.
I feel like it's safe to tell you use high and low. Let me double check.
Cause like. You know what I'm saying?
No, I'm sorry. Your high and your low X values. So your X values. I'm forgetting a word. X values. Your high and your low X values.
Okay.
I was like, I'm forgetting a word in there. No, your high and low of your X values. I'm sorry, guys.
That makes I was like, how am I doing this?
Yeah, no, high and low X values. You know, words are important, right? So they wouldn't give you this big of numbers without a calculator. Don't worry. Yeah, no.
That takes so long, right?
I would be shocked if they gave you
More than one decimal place.
without a calculator. Like that 0.5, you know how
Like you're just like using your time to multiply. That's not like 3 counts. Wait, how many numbers do you want to round up to?
let's just do 3.
Like all the time that I've been saying, so use calculators for the basic, like.
Oh, don't do that. It means 0 calculator.
How many does you got?
Involving years, do we just, use the actual number of years itself, or do we go down to like? 1, 2?
Remember we talked about forcing that 0?
Yeah. But even if you use it. you're
It's just
using
gonna-
the same number anyways.
Yeah. And I think they'll support it either way, because it creates 2 separate equations. So if you use years, you're gonna create one equation, and if you use 0, 1, 2, 3, 4, 5, those are gonna be 2 different answers.
Is 2012 and
So.
9 and 26.
I recommend using the smallest number as possible.
Oh.
I'm not sure.
Huh?
That's why one.
If you, if you're on 6, 4 plus 0.12. So it's 4,
So in the example that I got, so the example that walks you through from AP College Board, they actually don't force 0, they force 1. So like for them, they call 2006 is the 1.
Wait, so should we do it weird, but? We should have moved 1 and not.
No, we're gonna do just the rush models. But they start this as 1, 2, 3, 4, 5, 6, 7.
How is it 6 and 6? And I did it.
I don't know what to do.
Like that.
But I mean, if you think about it, if you're starting at 0, it's gonna be 6 minus 0.
Yeah, because it's 12, starting at 0, that's I'm saying it rounded. No, that's implying that like then that is a Y value.
7, 8, 6.
From this problem, yeah. So that's why, but in pre-algebra 2, they have us forcing you at 0. Remember, it was all about this is your 0, this is your 0. And when we were doing algebra 2, yes.
So right now we're using those.
So right now, you're either gonna use 2006, or we're gonna model it with AP pre-cal, which is forces it at 1.
So we can put a 1 if we want. Okay.
You put 1 if you want,
But we could use those.
Your resulting value is gonna be the same, your equations are gonna be different. Does that make sense?
Oh. I'm saying, it, when you go to the.
This is gonna be the same. Because you're gonna be 6 years apart. But does it matter if you could use that? You don't feel gonna be. 6 years apart. Does that make sense? Oh, yeah, so then it's gonna be the same, so whether you make it 1 or 0, and your figure is still gonna be a 6 year gap minus, yeah, trying to keep something. That's your, wait, now, yeah, minor, yes, it's 7, so you can this one or that one. So I got all of that, and then you fit 8. It's helps a lot, change your life. Remember, you're wilder.
It's never wired, so like, we get to that, it's totally wired.
Like what I said, your equations are gonna be different. Your slopes are the same, but your equations are gonna be different.
Yeah. And you still.
I won't know how to do it, when you do whatever you're comfortable with right now. You show the work to support what you did. You show the work to support what you did.
Yeah.
Yeah, I've reached the point in my life where my phone, when I'm reporting your graduation. Or after, I rather, either way, I swear, pointing that out even more.
How do we get out of it? I have my thing.
You have your.
On Monday, but like. You're getting a good setup from the school. And then.
Did you use?
But this is what you do when it's like. They were saying, right, they're like. I would do that with school 4 days. For your 20. And then at the end. Oh. Is this?
We have 9 periods. That's the thing.
Everyone else is like, they get on like this.
Okay, once you have your equation, I want you to use the one you created to answer what was the price in 2014 and what was the price in 2015. Of mortgage.
Miss, come here. Wait, you want to surround it to two? Because I have 3 days.
Right now you have 3, but when you tell me the price is less.
Does that make sense?
Okay. I would.
Okay, I'm gonna check. I'm gonna check. I'm gonna bring it. No. Please.
Wait. Oh, okay, I didn't see your one. I was like, wait, what? No. I didn't see your one. Oh, I thought you said you were still trying to get to these ones. And I was like, wait, what? I was like, girl, I was confused. I was like, I think you're wrong.
I think not.
I see it now. Your 2014
Yeah, it
was kind of lower than I thought.
Round down, let's round up on the money.
Down.
Down, round up.
money around.
Where,
People round down. Things that can't be cut. Oh, when he owes you money, of course, if I owe you money, I'm like, oh yeah, $5.50. Oh, no, I only owe you $5. All right. Hopefully this is a skill, remember.